I think what messed it up is, oh wait, this might be working. I did a test event earlier, and I think that screwed things up. All right, let me wait for confirmation from Christina that we're actually live. Okay.
Yeah, I see it on Twitch.
All right, fantastic. It's working. So we will go ahead and 1 second. Get this thing recorded. Hello, everyone. My name is John DeGose, and I am the CEO of Golem Cloud. And today it gives me great pleasure to welcome you to the official launch event for Golem 1.0. So the story, the origin story, if you will, for Golem goes back more than a year and a half ago. And at the time, I got this crazy idea for a new type of cloud computing platform. And the defining feature of this new type of computing platform would be its ability to run your software invincibly. And what I mean by that is if your software is running and someone does an update or someone does a restart or Kubernetes kills a pod or there's a server crash or maybe the operating system fails or maybe hardware fails, then your software continues to run unmodified. And that of course has to happen by relocating that running software to another machine and restoring it, including all of its state, to the moment before the failure event happened with no loss of any information. There was just one little tiny problem with this idea. It was crazy. And honestly, I didn't know if it could possibly work. I had an idea about how to do it, but of course I wasn't sure. So what I did is about a year and a half ago, I flew in about, I think, 4 or 5 of the finest engineers that I've ever had the pleasure to work with to the Highlands of Scotland. And we rented a small co-working space, and we had 2 weeks to either prove or disprove whether or not this idea was actually possible. And so we started hacking. We hacked days, we hacked nights. And I think it was about a week and a half into this 2 week hackathon session where we had something that would actually run. And there was this moment where we were going to run it. And I thought to myself, I need to get this on video. Why? Because if it actually works, then this event could go down in history as a landmark event. I'm not saying front page news or anything, but maybe, page 2000 or something as a footnote. This event could go down in history as changing the way we build modern cloud computing applications. And so I took out my phone and I started recording. And today's a special day. We've been working on this thing for a long time, and we're very proud of what we came up with. So to celebrate the launch of Golem 1.0, I'm going to take you all the way back in time, and I'm going to let you see that video. Because I want you to be there in that room, in that tiny co-working space, all huddled around this table, looking at Daniel Vygotsky's laptop screen, wondering whether or not this thing is actually going to work. So what I'm going to do is share my screen. Kick this thing off. And hide. I would like to hide that thing at the top. Maybe I'll just go full screen instead. Oh, and audio. I think I need to make sure that the audio is going to want you to hear the audio. And honestly, I'm not sure how to do that. Okay. Let's see here. Does anyone know how to share the audio of my computer?
There might be a setting like when you start the screen share.
I am screen sharing, right?
Yeah. But it's like when you're doing that, like in the modal that pops up, I think. Like I
Okay,
believe there's
let
an
me
option.
try that again. Yeah, thank you. Sorry for the technical glitch. Okay, there we go. You were exactly right. That's it. All right, you ready for this? Here we go.
Okay, so let's start Golem Cloud locally.
I don't hear anything.
Starts up
I hear it
cloud
though.
services, which
Okay.
is Scala service. Compile some Rust code. And this is the Scala server running. This is our Rust instance server running. This is Redis
There were so many things that could go wrong here.
instances. And let's start this small test script. So first we are uploading a component WASM to our Golem Cloud and get back the exported functions from this component. And we create a new instance of the instance server. And we start invoking these exported functions to build a shopping cart. The green lines are coming from our WASM program through WebSocket. So we have 3 different kind of items in our shopping cart. We can see that the Rust service was logging out a lot of different debug messages. It's still running, and now we kill and restart the service, only the Rust instance server. Coming back here, instance server is running again, hopefully. And let's try to invoke more functions. It worked. And now we have an updated state of the shopping cart. And that's it. Let's try to verify that it actually restarted.
Did it work?
Because there is I think so, but yeah, if we can see, because
It's unobservable whether it went down or not.
No.
That's exactly the goal.
Golem instance server starting up, and it says recovering instances, and recovering instance 1, which is our shopping cart instance. It re-downloaded its component because not caching it yet, and it just replayed all the operations that look exactly like it looked like before in the log, so that's why it was not clear.
Wow, and we have all the original shopping cart entries.
Yeah, we saw that.
Yeah.
Wow. Huh.
Yeah,
Amazing.
because
Fantastic.
Hold on.
if we go back here, first we had
Almost.
5 t-shirts and
All right. Well, I feel like clapping after that. I think we celebrated that day. I think that was a very good day, because what we had just done is we had de-risked the idea that this type of technology, which makes your running software invincible in any programming language, and without even having to use a particular SDK, was actually possible on commodity hardware. So that was about a year and a half ago, that video. Fast forward to today. Today is the official launch of Golem 1.0. And this is where the story starts, not where the story ends. We really do believe, after seeing this type of technology and working with it over the past year and a half, we really do believe that Golem and other solutions that are similar to Golem in the same space are going to end up changing the way cloud computing is done forever. This is an event, because the future is not going to look like the past. We've had to deal with lots of pains. Getting to this point, however, marks the next chapter. It's the step that comes after cloud computing. So today, I'm going to talk about why Golem. I'm going to try to motivate. Why should you even be interested in a solution like Golem? And then I'm going to tell you a bit more about what Golem is. I'll try to keep that brief, but I'm going to give you a high-level intro to Golem, and I'll talk about some of the high-level features that Golem has that promise to radically simplify the way you build highly reliable systems. And then I think the centerpiece of this presentation is actually when I turn it over to my colleagues, Daniel and Afzal and Nico, who are going to live code, potential for lots of things to go wrong. They're going to live code a multi-user list editor. And they're not going to do this in weeks, or hopefully not even in days, but actually in minutes as you watch. And the solution they come up with is going to be extremely scalable and almost impossibly reliable. And they're not even going to have to use a database to do it. I think it's going to blow your mind. When you see what they do in a matter of minutes, it's going to blow your mind, especially if you've worked on this type of application before. And then I'll talk a bit more about a very fun upcoming Golem hackathon that we have scheduled for a week from tomorrow. And we will be giving out cash prizes worth more than $5,000. And it's your opportunity to get your hands dirty and see what this new open source technology is all about and what sort of applications you can build with it. So if you want to participate in that hackathon, note that you do have to register. And you have to register basically during this event. So see the link, please register now, just in case you decide to participate. And then finally, I'll wrap things up with a summary. All right, here we go. Why Golem? Well, if I'm 100% honest, if you go back about 40 years, probably before your time, this is your dad's time when he was building software, you actually didn't need a solution like Golem. Why? Because the way you built applications for mainframes back in that day is you would have your business logic and it would talk to a database. And anytime you needed to update state, you would just issue a query to the database. And the wonderful, magical thing about that is that a database provides you with atomicity, consistency, isolation, and durability, ACID. And so you would never have to worry about the state of your application being inconsistent. Why? Because the database was handling the problem of reliable state updates. And your app could focus on business logic, which is what you want to be focused on. You don't want to have to worry about failure scenarios and this and that. You want to have to reinvent your own database. You want to focus on business logic and let the database handle reliability of state update. And all was well and good, but over time, of course, our systems are no longer centralized like this. They've become distributed. And that's why I'm going to argue that every one of you developers who are listening in today is in fact building, if you're building modern cloud systems, you are building distributed systems, right? Add that to your LinkedIn profile. You're a distributed systems engineer now. Why? Because the applications you build don't look like this. No, of course you're talking to Postgres or whatever sort of relational database system you're using, but you're also talking to maybe a blob storage. You're also talking to Stripe or PayPal for payment processing. You're also talking to a document database like Amazon DynamoDB or MongoDB or something like that. You're also talking to a service like SendGrid to send emails. You're also talking to caches like Redis. You're probably talking to Apache Kafka and lots of other different systems, and maybe tens, maybe even hundreds of different APIs. And what has happened over the course of these 40 years is the state of your application, the applications we've been building have gone from being stored in a relational database, which gives us transactions, transactional state updates, to being stored a little bit here, a little bit there, a little bit everywhere. Why is this a problem? Well, it's a problem because let's say you're building an app, some request comes in, and what you have to do is you have to coordinate a bunch of state updates across dozens, maybe hundreds of different systems. The collective combined state of your application is no longer stored in just a relational database. It's been scattered across hundreds of different systems. And that doesn't sound so bad until you think about all of the ways things can go wrong. Even if you write code that has no bugs, you can still be in the middle of handling a request, and you could have called out to this API to do authentication and call this API to update some data here. Maybe you issued some sort of query to your relational database, and then something goes wrong. A developer pushes out a new update, or Kubernetes kills something, kills the pod that your software was running in, or maybe the server is restarted. Someone changes configuration, the server is restarted. Or maybe the server crashes because of out of memory or Stack Overflow or something like that. Maybe the operating system has a fault, the blue screen of death, etc. Maybe hardware fails. It doesn't matter what it is. All of these failure events are going to bring your running code down. And when they do, the state of your application, not being defined by the state of relational database, but by all of these different systems that your application interacts with, is now in an inconsistent state. And for some applications, maybe that doesn't matter, but for the vast majority of applications, this inconsistency is going to lead to effects that are negative for the business. An example is a customer pays for an order that they never receive. Why? Some failure event like this happened when your request handler was midway through execution. So what does this lead to? It leads to something that I'm calling the pain equation, which is basically the story of building modern day cloud native applications. What we really want is we want a transactional way to update a bunch of systems. And we want to have very, very strong guarantees on that, such that it doesn't matter what sort of failure event happens, our code continues to execute all the way to completion without loss of state. But we don't have that. And also, because we don't have that, we can't program in a stateful way anymore. Microservices are stateless. All your servers are stateless. All your functions as a service and lambdas and all of that, they have to be stateless. They have to push state elsewhere. Why? Because if there is a failure event, none of that information that was in memory is going to be preserved. It all goes away. So this forces us to use radically more complicated architecture. We're using multiple databases, we're using caches, we're using queues, we're probably chopping up our business logic into like discrete little units of information called events that we can serialize. We do event sourcing or some other event-driven architecture. You've got all this crazy persistence code going in our applications. We're talking to different APIs, different databases, and it's monumentalously complex. You can build highly reliable distributed systems, right? There's no doubt you can. And we do it all the time, and I've done it many times myself, and probably most of you developers watching this have done something like that before, but it's not easy. It's way more complicated. It's a recipe for pain, and it's a recipe for a world in which we spend all our time working on failure and very little of our time working on the actual business problem that we're trying to solve. So that's the setup for what Golem is. What is Golem? Well, it turns out that Golem sits at the intersection of three overlapping circles. And one is, of course, distributed systems. And by distributed systems, I don't necessarily mean just the engineers who are off building distributed databases, right? Obviously, they need to solve many problems of distributed systems engineering, but I'm actually referring to you and me, right? All the people building business applications. And the business applications you build today, they just talk to lots of systems, and the state is scattered across all these different systems. And so you and I, even if we're not building a distributed database, we still are building a distributed system. And simplicity, by simplicity, I mean, how much time, what percentage of your time do you spend working on the business problem, which is what you want to be working on, or at least what the business wants you to be working on? And what percentage of your time do you spend engineering around failure and serialization and persistence and all this other stuff that comes when you're dealing with a fragile computing platform? And then by reliability, I mean that sort of magical property of highly reliable systems. That means no matter what failure event there is, whether it's Stack Overflow or whether there's a hardware or software failure or operating system failure or infrastructure turnover or application update or restart or config change, it doesn't matter. That system continues to update states across every distributed system that it interacts with in a way that's correct and consistent. And achieving that is very, very difficult in the context of distributed systems, and it's impossible to do if you want to keep your code simple. So that leads me to my one-sentence pitch for what Golem is. Golem is a durable computing platform that radically simplifies building and deploying highly reliable systems. I will be careful here. I want to underline and bold that word radically. I really do mean it. But you're going to see in a few minutes here whether or not that claim is true. And I think after you see my colleagues' live code, this multi-user collaborative list editor, you're going to see how much potential platforms like Golem have for radically simplifying building and deploying highly reliable distributed systems. And this definition here actually begs the question a bit. Well, if Golem is a durable computing platform, what is a durable computing platform? What is durable computing itself? And it's basically a new way of executing running software that uses continuous state replication to provide automatic fault tolerance. And that's what Golem gives you, is this automatic sort of background continuous state replication combined with supervision to make your code fault tolerant to virtually any kind of fault. And there's one additional aspect of Golem that it's worth talking about now, maybe, and that is Golem is a serverless computing platform. It's not just a durable computing platform, but it is also a serverless computing platform. And that, again, is one of these things, one of these decisions that is designed to help you focus on writing business logic and not writing servers, not writing protocols, not writing HTTP stuff. Write your code. You're going to see how this works in a few minutes. But for now, just think in your mind, Golem is a platform where your business problem steps up front and center, and you focus on that. And all this irrelevant stuff about, ports and HTTP protocols and this and that, you can let fade away into the background. You don't have to think about reliability. Golem helps you focus on solving your problem, and you're going to solve it in a simple way that's going to give you something that's way more reliable than you ever thought possible. Now I'm going to walk you through some of the high-level features of Golem that make a real difference in how easy it is for you to build highly reliable distributed systems. And the number one feature here is something that I'm calling transactional execution. 40 years ago, the database gave you transactional state updates within the context of the single database. Fast forward to today, well, our data or application states scattered among dozens or hundreds of different systems. So it's not enough for a single relational database to give us transactions. Rather, we're not using SQL to update all of these different systems. We're using, in fact, ordinary application code. Call this API, call that API, make this query to this database. So we need more than just transactional SQL. We actually need transactional code. And that's what Golem gives us, is this ability to execute your workers, your serverless workers, transactionally in a way that's totally impervious to restarts, updates, and faults. In addition, Golem gives us this other property as almost a side effect, a beneficial side effect of that first one, which is durable state. So all state in your workers is actually persistent. It's automatically persistent. You don't have to do anything, and it has the same guarantees as a database, which means suddenly Golem opens up the door to using memory, like hash maps, maps, lists, whatever, just in-memory structures instead of databases. And that's mind-blowing, and you're going to see that in the live coding demo in a few minutes. You're going to see how it's possible to build this massively scalable, highly reliable system where everything is persistent and we didn't even have to talk to a database a single time. Golem also supports this feature called reactive workers. So if you're familiar with serverless paradigm, you tend to write basically what's a request handler that's triggered on an event, like an HTTP call. And then the cloud platform executes your worker for you a single time. Golem has actually reactive workers, which means that your workers can expose not just a single function that's called when the worker is triggered, but they can expose lots of different functions. And your workers are not one shot. They live forever, actually. And so you can keep calling the same worker with different functions. And this opens up the door to radical simplifications in the way that you build distributed systems. And it opens up the door to some applications for basically deleting your database. You don't even need a database when memory is as reliable as a database. Golem also features, which is fairly unique for Lambdas and function as a service platform, it features long-running workers. So workers can run forever. In fact, they do run forever. All workers run forever. I mean, they don't consume active resources unless they're doing active work, but they're basically immortal. And they can perform work, active, useful work, over days or weeks or months or years, which allows them to orchestrate long-running business processes and be used for other sorts of workflow-oriented use cases. Golem also has very, very broad horizontal scalability baked into the product from day one. You deploy Golem in Kubernetes, for example, Golem will partition all of the workers across any number of nodes, and it's going to consume more resources, and it's also going to scale down by pushing things out of memory and CPU in order to keep things efficient. Golem also supports a feature that we call worker-to-worker communication. And a microservice-oriented architecture, everyone talks to each other through protocols like HTTP or gRPC. And that's not necessary with Golem. Basically, Golem says, throw away those protocols. Your workers should be able to talk to each other using a type-safe API directly without you having to write any protocols. And that's what worker-to-worker communication is all about. Golem also provides reliable communication. So when one worker calls another, it's automatically reliable. It doesn't matter what happens to the infrastructure. If you call another worker, it's not only is it reliable, and by reliable, I mean bulletproof reliable. There's nothing that can take that down, but also you get exactly once semantics. If your system is calling a third-party external system, like you're calling over into that API over there, then you're going to get at least once semantics if that system does not support idempotency keys. If it does support them, then you'll get exactly once semantics. And if that system is being flaky, like there's no way we can control and make reliable third-party systems, like a random API in the cloud, we can't make them reliable, but we do implement automatic retries for those failures. So that means if they're being flaky, your code is probably not even going to see it, because if there is a failure, we'll just retry that and we'll keep on going, and you'll just see suddenly, magically, all these external systems becoming highly reliable compared to what they would be if you didn't have Golem. Golem also lets you construct custom APIs custom REST APIs, and in the future, custom gRPC or GraphQL APIs in a very simple, lightweight way. And these are like open API compliant APIs that will delegate to your workers without you having to write any servers. So you get the API you want while still being able to focus entirely on your business problem. And then finally, Golem lets you perform live updates on workers that are currently in progress. This amazing ability. Basically, if you have long-running workers, sometimes they might have bugs in them that you need to go out there and hotfix, so to speak. Or maybe you just want to add features to workers that are intended to run forever. And you can do that with this live update feature that lets you push a button and then basically bring a worker up to date with the latest version of a component if such a transformation is possible. All right, so now the part you have all been waiting for, which is my colleagues live coding a multi-user list editor that is extremely scalable and impossibly reliable. And they're going to do it in a matter of minutes. And you're going to get a chance to see many of these features. You're going to get a taste for what it's like to building applications on Golem. And what you're going to see more than anything else is that Golem lets you focus on the business problem. There's no infrastructure to think about. There's no failure scenarios to think about. There's no databases. There's nothing. It's just your business problem, front and center. And I'm not using hyperbole when I say that for many classes of problems requiring high reliability in a distributed systems context, Golem is a multiplication factor of 10 or even 100 times. That is to say, I challenge anyone to build what my colleagues are about to build in minutes. I challenge anyone to build that using event sourcing and all these other complicated technologies in less than a few days worth of time at least. And we're going to build it in minutes. So without further ado, I am going to stop sharing and let Daniel Vygotsky take things over. Daniel, please take it away.
Thank you, John. So let me try to share my entire screen. And hopefully you are seeing my browser now. So before starting this live coding event, I wanted to just say a few words about what you need to get started with Golem. And basically you need three different things. You have to have Golem running somewhere, Golem Cloud, a couple of services. And for that, there are several options. We have our own hosted version of Golem called Golem Cloud, which you can use for free. But as John said, it's an open source technology, so you can also run it in your own computer or in your own infrastructure. And for that, we are providing a few ways. We are having a Docker Compose file that you can just set up on your computer to start up all the services that you need. We have instructions how to deploy it to your Kubernetes cluster. And of course, it's also possible to just compile the whole thing to native executables and start the processes on your computer. That's very useful when you are actually developing Golem. So that's the first thing that you need. The second thing, we have a command line tool for working with Golem. And to install it, once again, there are several options. You can, for example, download our precompiled binaries for various set of platforms, or you can, it's a Rust tool, you can build it from source with Cargo and use it like that. And the third thing that you need to decide what language are you going to use to write your Golem applications. And in this website, learn.golem.cloud, we have a section for each supported language. And if you click on one of them, each one of them have a setup page which gives you detailed instructions of what version of the compiler you have to use, what tools you have to install if there is anything. So with these three steps, you are ready to work on Golem applications. In my presentation, I'm going to use Golem Cloud, so I'm not running the services locally. And a few words about what we are trying to build. So as John mentioned, it's a collaborative list editor application. And so the idea is that you can create an arbitrary number of lists, and lists are just very simple things. Something that contains a list of items. You can think of a to-do list or a list of ideas, or you can use it to anything like that. But any number of users can simultaneously modify these lists and of course query them. And we are going to make this a little bit more real-world-like by maintaining a list of connected users, so you know who is editing the list in a given point in time. And we are going to introduce a feature where you can archive a list. And you can no longer edit a list if it's archived, but you can query all the archived lists together. And finally, we are going to add a feature where if a list is not archived and there is no changes for it for a certain period of time, like 12 hours or something, then all the connected editors will be notified by sending an email. We are not going to actually implement the email sending part, but everything else is going to be prepared for that. So I will start coding now. I will switch back to this Markdown file from time to time just to copy out commands and to not forget where I am. You don't have to read it. I will share the whole repository with the instructions and code and everything after the event. So we will start with a very simple version first, and we are going to implement it in TypeScript. So the CLI tool we have has a command called new, and you can specify what language you want to use. Here we are using TypeScript. We are going to create a Golem worker, which is called list. And by just running this command, it creates us a new project, a default project. We can see we created a directory called list, which is a TypeScript project. And if we go there and do npm install, and I hope it's going to be fast. And then we are going to do npm run componentize. This is a special command that compiles the TypeScript code and in the end outputs a WebAssembly component. And this WebAssembly component, which is in the out directory, is ready to be uploaded to Golem and run there. So there is nothing else you need to do. So now that we have this example project, it's of course not a list editor. So let's see what we have here. We have a TypeScript file. We'll get back to that very soon. And we also have a directory called with, which is WebAssembly's interface definition language. And with Golem right now, we always have to write our components specification first. We have to start with this interface definition language. So let's do that. The thing that was generated by the Golem CLI tool is a counter. It has an add and a get method. That's not what we want. Let me copy my prepared with file just so I should really use the same names and everything that I was preparing with. So we changed this counter interface to a very simple interface where we have an add function that takes a string. We can delete a string, we can insert one item after another, and we can get the list of strings. So this is the simplest possible interface that I could come up with for this list editor application. And as you can see, this entity here represents one single list. And as I said, we are going to support an arbitrary number of lists, but that is basically coming for free from Golem because we are going to spawn one Golem worker for each list. And the worker's name will be the list's name, and its contents are managed by one instance of this application. So if we try to compile this again, it's no longer going to compile because we changed the interface, but we didn't change the implementation. So let's go to the TypeScript file now. And this was the generated implementation of the counter. Let's see what we need. We definitely need something that holds this list state. So let's create a class called state with items of strings, and an empty constructor will do. And we change this to have a global variable which holds our state. Why not? And we delete these methods here and let the IDE generate the things that we have to implement. All right, so how do we implement this? Just let Copilot implement it. But yes, it seems like it knows what we want to do, although I want to remove redundancy here and just call the add function. And we are returning the items. And let's try to compile this again. And before going forward, I will just add some logging as well. And compile it. And basically that's it. That's the first version of our list editor application. It's compiled to WebAssembly. Let's try it out. So first, I will just define this environment variable here. Projects are a feature of Golem Cloud, which is basically just a collection of components. I created an empty project for this live demo, and I'm just storing it in an environment variable so we don't have to copy it to each command that we will do. So the first step of trying this out is using the CLI and upload this WebAssembly file to Golem Cloud. It's called component add, and you just give a component a name and specify where the file is. This might take a while. My network connection is not the best. Sorry about that. But eventually it's uploaded and it prints this interface that we were specifying with the wait file. And it has this URL that identifies the component. I'm going to store that as well in an environment variable. Okay, so now that we have the component, as I said, we are going to spawn a Golem worker for every list that we want to store. So let's use the CLI to invoke this exported API. First, we say that we are using the component list that we just uploaded, and we are calling our worker test1, which is going to be our list title, basically. And we are calling the add function with an argument item1. And then do one more of the add call. And we can try out the insert call as well. And then finally, we can call the get to see if it really worked. And if I add this connect parameter here, then we are also going to see the logs that it emitted. So yes, this worked. But of course, yeah, you can say that that I was cheating. This is not a real application. It's just a global variable and a few lines of code. But the thing is that this is a completely valid full Golem application that will run in Golem forever. If you spawn this worker and call these methods, the state of this list will never go away. You don't need to do anything else. So we are done with the first version. So in the second version, we are going to make this more complicated by introducing the concept of connected editors of the list. And as I said, it's specification first, so let's go back to the width. And I will use my prepared one once again, because I cannot remember the syntax of the width files. And let's see what we are doing here. So we are defining a new type called connection, which is just holding a numeric identifier. And we are adding this connection as a parameter to all the 3 functions that are editing the list. So you cannot call these functions anymore without having the connection. And to get the connection, we are defining a function called connect, which takes an email address and gets back a new connection that you can pass to these editing functions and also the current state of your list. And of course, you can also disconnect if you want to, and there is a way to get the actually connected users by getting their email addresses. And the last thing that we define is a poll function. So if you are a connected editor, you can call poll and it will get you the list of changes since your last call to the poll function. And of course, this is per user, which can be a good foundation for building a nice UI on top of this problem. And the change is a data type, which can be one of these 3 cases. And this just holds the information that is passed to the editing functions. So let's try to compile our list component again. And of course, it's not going to compile because we changed the interface again. But by running the compilation, it generates the TypeScript binding, so that's why I'm doing it. Let's go back to TypeScript. So what do we need for this? We are going to need to store information about connected editors. So let's define an interface editor state and email. And I will call it event and store a list of changes. And change is a type that is coming from the with file. The tooling generates TypeScript bindings from our interface definition. So change is something union of added, deleted, or inserted. Okay, so we need a map of these editor states, and it's going to be a map from number, which is the connection ID, to editor state, and we are going to have a last connection ID, which is a number. And what else? We need to fix the signatures here. Here and here and here. And implement the new functions as well. And I'm going to add a few helper functions here. Is connected, not like this, like this. The has to be converted to a number because it's a big int or whatever. And the other is going to be a function that is adding an event to all the connected users event list. Something like this. So first thing we need to do, we don't want invalid connection IDs to allow editing our list. So we are going to check this here. And if it's not a valid connection, of course, we could create some proper error handling here, but we are not going to do that now. So we are just logging an error. We could change our interface definition to not return void, but return some kind of an error in these cases. That's not part of the demo now. Let's add this to all of the methods. But we are still going to allow getting the list contents without connecting as an editor. This is only for editors. So let's implement the new functions. The connect has to return current state, and also has to create a new ID. So the will be last connection ID, and we store it back and return it like this. And the last thing we have to do here is, yeah, this. Okay, I don't even have to write anything. So let's log something as well. Here we are going to return, just enumerate this map and get out the emails out of it. And in the disconnect, we delete it by its numeric identifier. So what about the poll function? Basically, we are already maintaining everything for it. We just have to return this list of changes that is stored for every connected user and reset it. So let's see if this is what we need to do. And exactly. Yeah, so we are going to have to believe this here. Actually, yeah, I'm not, I don't remember how to write TypeScript code. Let's see what I did in my original code here. Yeah, yeah, like this. That's better. Sorry about that. All right, so let's see if we can compile this. And we can. And once again, I will show that it actually works. So now we already have a component called list in our Golem Cloud project. And we don't have to create a new component just to upload our new WebAssembly file, of course. We can update the existing component. Let's do that. It's called component update in the CLI. And we are just loading this new WebAssembly file. And once it's uploaded, we are going to see that it's the new version by seeing all these new interface, new things on the interface. And one very important thing is that this changing this WebAssembly file, updating to a new version didn't affect the existing list in any way. So if we do Golem Cloud CLI worker list, component, and this lists all the workers, basically all our lists that we have defined so far. It shows that test one is using component version 0. So uploading new versions of your code is not affecting your existing code. Only if you want to. You have to explicitly say you want to update this and this and this worker. So let's try out. And how do we try out? We don't want to update our test one now. We're creating a new list called test 2. And if you create a new worker, it's always using the latest version of your component. So it's going to use our new version. And then we no longer can just call the add method immediately. We need to first connect. So let me connect using the connect function. It returned the connection ID 1 and an initial state of empty list. I'm connecting in the name of John as well. And I'm just going to add a few items like before, but now I'm passing the connection ID as well. And just quickly get to something that is more exciting. So now we have 3 items added. And that is the same thing that I demonstrated before. But now we can also get the active connected editors. And that works. And now I can call poll in the name of user ID 1. And that is supposed to return all the 2 add and 1 insert events that we had. What did I do? Oh, I didn't properly implement the function. Maybe just let's see. Oh yeah, we forgot to do one thing. So this add event is not called anywhere right now. So let's do that. And this is exactly that case when you would want to use worker update, but I didn't try that, so I will probably not do that now. But actually we can try. So first, what we do is compile this again. And update the component itself. But yeah, we probably cannot update this automatically. So let's just rerun the script, sorry for the confusion. Let's connect again once it's uploaded. So the reason why I'm saying it's not possible to update it. Oh, now I connected to the, yeah, I can no longer use the test2 name if I want to run the new code version, as I said. So it will be test22. And I'm not going to call all these again, just I want to demonstrate that the poll function works. So the reason why you cannot update the worker after this change is that it is changing what it's changing the interface basically, and that is an incompatible change. If you already called something that has a changed interface, like for example, we added something to the add method, then you cannot do this. So we are adding one item, and now I'm going to call the poll function again. Now it's going to work. Yes, it returns the event, and let's add one more item. And call it again. Yeah, and it's only returning the new event because it remembered that we already called once. But if we call poll in the name of the second user, it's going to return both of the events. Yeah, so that's what I was trying to show in the first time. All right, so second version is done. It's slightly more complicated. It maintains a list of connected users and per user list of events and so on, but we still didn't have to do anything else, just write the simplest possible TypeScript code that can store this in memory, and it still works and it's still fully reliable once you once you added an item or created a connection, that is never going to go away. Okay, so the third phase of this demo is implementing the archive functionality. And here, what's interesting is that we can no longer just continue adding new stuff to our list worker, because as I said, the list worker is pair list. So every instance of this component represents one single list. And in the archive, we want something that holds all the archive lists together. So we cannot just code it into our entity that represents a single list. So we are going to create a second Golem component. And just for fun, we are going to use Go this time for it. So we go out one level up. And once again, we are going to use the CLI to create a new project, but now the language is Go and the name is archive. We go to archive directory, we can compile it with make. And you can see that very similarly to the TypeScript example, We have a vit directory and we have a Go file, and it's actually the same counter example of having an add and the get method, and it's implemented in Go by having a global variable and two functions implementing an interface. So once again, let's start with writing the real interface of this component that we are trying to do. Once again, I'm copying it from here. So here we are going to have two functions. One is called store. It gets the name of a list and it gets the contents of the list. And we have a get all function, which is returning all the stored archived lists, which is a list of items containing a name and a list of strings. Let's regenerate the bindings and then try to implement this in Go. So, oh, not here. That's the prepared implementation here. So we don't need these things. We don't want a global variable called total. We want something like archived. And it's going to be a list of this. And instead of these two functions, we need a store function, yes. And this is printing something, printing the name of the list that we added to the archive, and then just appending a new element to this global variable. And the other function that we need is called getAll, and it's just returning the current contents of this global variable. This is for this example, but it's what our template contains it, because it sets up a few things to work with Golem. So to make HTTP calls and environment variable access working, you need to call this in the beginning of your function. You are not using those, but it's a good practice to just keep it there so you don't forget it. So let's try to compile this. And we are going to have, yes, we are having an archive WASM file here now, which is going to be a singleton worker. So we only want a single instance of this in our list application, unlike the list worker, which is something that is found for each list that we are creating. So now the only remaining question is, who is going to call this store function, right? So one possibility would be to orchestrate this externally. So you want to archive a list, then you query the contents of the list and call the store function from the outside, like I can do it from my command line using the Golem add the list component one more time. And we are going to add two new functions to the list interface called archive and isArchived. And go back to the list directory and componentize, so we have it. And it's not compiling now. Let's see what we need to do to compile this, to make this compilable. So we first of all have to implement these two new functions. And we add a new flag to the state archived. And we are not going to allow any editing operations if this is true. So we are just adding this here. And we should update the log messages in the else branch, but I'm not going to spend time with that right now. And so here we definitely need to do something like this. And here we want to return this. But here we need to do something. We need to somehow get the current contents of our list and call the archive worker and store the list elements in it. So to do that, we are going to use the feature that John already mentioned in the introduction called worker-to-worker communication. And by using worker-to-worker communication, we get a completely type-safe generated interface where we can call one worker from the other, no matter what language it is implemented in. So to do that, there are a few steps which are not very interesting to see. So basically, we need to generate a stub for the thing that we want to call this. In this case, we are going to call the archive component. So we need to generate a stub for the archive component. I'm not going to details of why is this necessary or what does it mean exactly. It's documented in our website. And I even had a conference talk on Lambda.conf about it. If you're interested, you can watch it later. But we are going to just copy these commands from my notes here. First step is to generate and build the stub for the archive component. And then the next step is to add this generates a new WebAssembly file called archive stub in this subdirectory. And the next step is to add this generated thing as a dependency to our list worker source code. And now that we did this, if we go to our list workers with depth directory, which we haven't looked at yet, it contains this new demo archive stub thing that our CLI copied there. And this allows us to use the archive component's exported interface in our list component. But before doing that, we have to import this in the with file, unfortunately, like this. And now, if we go back here again, it will already compile, but it's not doing yet what we want. Yes. And now if we go back to the TypeScript code, we can implement this missing part. And I'm going to copy paste it, sorry. Because it's more than 3 lines long. So what we have here, first of all, let's start from the bottom. So here we are actually calling the store function on our archive worker. And we are passing a name, and we are passing our current items. So to call the store function, it's not enough to know we want to call the store function. We need to know which worker exports this store function that we are going to call. So we need to construct this URI or URN, which specifies which worker to call. And the URI like that consists of a component ID that will be our archive components identifier once we deploy it to Golem Cloud. And the name of the worker. And as I said, this is a singleton worker, so we can hard code the name here in the source code that it's always called archive. But we cannot hard code the component ID because that is something that we only know once we deployed the archive component. It's not something that we can predefine here. And because of that, we are going to get it through an environment variable. That's the simplest way to inject configuration into workers in Golem. So we are going to query the archive component ID environment variable and use it to construct this URI that tells us which worker to call. And the other thing that we are getting from environment variables is the worker's name, which is basically the list's name. Because you may notice that we never stored the name of the list anywhere here because it was just implicitly coming from the name of the worker. But Golem stores or injects the name of each worker to environment variables so you can access it. And by that, we have all the information to archive our list. And Yes, it's imported. Let's try to compile it one more time. Compile. So we are almost ready to try this out. But there is one more step, which I'm not going to fully explain now, but we have to use the compose subcommand of our CLI to convert this WebAssembly file to something else by basically composing our application with the generated stub together. And if I do that, and I have to go out, then we get basically a new WebAssembly file here. And that is the one that we have to update our application's code to now. But first, before touching the list component, let's upload the archive component. We didn't do that yet. So that will be a new component. So we use component add. And it shows its interface. And let's store its URL in environment variables. So I can copy paste my comments from my notes. Yes. And we can also store just the ID part, because that's what we have to inject to our worker later. So that part is done. And now we update our list component one more time, but this time we are using this compose WebAssembly file, which we generated from putting two things together, basically. Let's do it again. And now we are going to see two new functions in the output of this command, the archived and the is archived. Yes, they are there. One more difference from the previous demo is that we can no longer just start calling the invoke and await function on a new non-existing list, because we somehow have to inject the archive component ID to our worker. And the way we can do that is that we explicitly start the worker before invoking it by using the worker start command, giving a new worker name. So we use the latest component version that's called test3. And with this last parameter, we are basically just setting the environment variable that the list worker will be able to read when it tries to archive itself. So it knows that our deployed archive component is identified by this ID. And now that it started, we just do a few of the same calls that we did before. We connect with one user and add one item and another. And see if it has the items in its state. Yes, and now we call one of the new functions called isArchived, and it's supposed to return false. Yes. And we can check what's going on with our new archive component. So as I said, it's a singleton. Let's see if it exists or not. We are listing all the workers of this component now, and it's an empty list. There is no archive component at all yet. So what happens if we call the archive function that we wrote? It's not going to write anything, but now if we query its state, it's going to be true. And if I would try to add new elements, it wouldn't add anything. I'm not going to demonstrate that. But if we list the workers of the archive component one more time, then we will see that now we have our singleton archive worker called archive. It's running, or it's in an idle state. And that means that now we can query it. We can call the get all function that we wrote in a one-liner Go function to see what lists are stored within it. and it contains our archived list. And if we archive more and more lists using our new API, it would add all those contents into this Go application's global variable, and you don't have to do anything as they are stored there forever. So that was the third part. And the last step that that is missing from what I gave as a specification in the beginning is that we want something that if you have, well, this feature probably doesn't make too much sense for this particular application, but in general, it will demonstrate another powerful capability of Golem of how you can schedule things, how you can do long-running workflows. So what we are going to do, if a list is still open, it's not archived, and nobody does any editing operation, then 12 hours from the last editing operations, we are going to simulate that we are sending emails. We are actually just going to log the email addresses into Summer. So the simplest way to implement this in Golem is to create one more component, which is going to be called email. And this time I'm going to use Rust just for fun. Where am I? Oh, yes. So one more time, we are using Golem CLI new, but this time using the language Rust and calling it email. And if I go to email and by the way, the CLI new command always prints the instruction that is necessary to compile the output to a WebAssembly file. So I'm just doing that. And probably it's no surprise that this is once again the counterexample. As we can see here, don't worry much about it because we are going to delete it anyway. So before explaining how this will work, we have to create something else again in the list worker. We will expose a new interface, completely new interface from our list worker by going to its with definition again. And I'm cheating a bit. So it's going to be called email query. And we had this API, which is supposed to be the user-facing API of our list. But we are also defining a different API, which is something that we want to expose to this new worker that we created called email. And it's going to have two functions. One returns the deadline when we should send the emails, and the other is returning a list of email addresses to notify. So the idea is that for each list, we are spawning a companion worker, which is an instance of this email component. And that email component will start as soon as the list is initialized, basically. And it will periodically query our list about the deadline that the nearest point in time when it probably has to send emails. And so it is going to wait the deadline, then query again, and once it passes the deadline, it's going to send the email. So first, what we have to do is implement this in the list component. Not compiling because we have to implement it. Oh, it is compiling. Yeah, the reason why it's compiling that I defined this interface here, but we need to export it here. Yeah, now it's not compiling. And this is the time when I'm not going to continue live coding anymore. Just to not spend too much time on this, but let's copy paste this version of the list component and go through the changes. So what we did, sorry. So this is not existing yet. What we did, we added a couple of things into the state again. So we will maintain this deadline and recipients that we are going to return from the new interface that we did. And we also need a flag called initialize. That reason is that we need to do something when the list is first used. An obvious place to do that would be the constructor of the state, but that doesn't work for various reasons. So we need to create an ensure initialized function here, which is only doing something the first time. And we are calling it at the beginning of each exported function because we don't know which one will be called first. So that's just something we need to do once when our list is first created. And that is the thing that will spawn our email worker, by the way. And the other thing we added is this update email properties function, which will be called after each editing. And it's just calculating the deadline, which is 12 hours from now. And it also stores a snapshot of who was the last active connected users who we would send these emails to. So if we look at this update, oh, it should be called here. I think I had the wrong version copy pasted anyway. So the idea is that every time that an editing is happening, we are moving the deadline away to the future. And then in the initialize function, ensure initialized function, what we do is we are going to do the same thing that we did with the archive thing, get some environment variables, use this interface of the email worker, which we haven't written yet, and then just initialize it in a way. But let's comment this out for now because we don't have it yet. And yeah, of course, the implementation of the new interface is down here as well. But that is really just returning the two things that we stored in the state. Unless it's if the list is archived, then we are returning undefined, which represents that we no longer want to send emails. So the email worker that we are going to write will detect this and just cancel itself. So now if we compile this again, it will compile. And let's see how the email worker would look like. I will just copy that as well. And first, the scan specification first. Let's copy its width definition. So it's exporting a single function called send email. And this is basically just, it will be a long-running function that is responsible for sending the email whenever it's needed. And we will see how that works in a second. Let's copy the Rust. Yeah, this is now a Rust component. Let's try to copy and explain the code there. All right, so this is the entry point, the exported function called send email. It gets a list URI, which is something that points to a list. As I said, there is a email worker corresponding for each list worker. So this is just basically a backward pointer to that worker. And then what we do is we do a loop. And in this loop, we first get the deadline by invoking the list exported deadline function. If the deadline is in the past, then we are sending the emails. And if it's in the future, then we just calculate the duration to get to the deadline, and we simply sleep using Rust standard sleep function. This will just block the execution for 12 hours for real. And we don't have to worry about this worker getting interrupted or restarted or moved to another other node in case of scaling, anything. Every time anything like that happens, your email worker will continue to sleep exactly the amount that it needs to, and it will wake up at the right time. And yeah, if there is no deadline, then we are just canceling this thing. So sending the emails is once again calling the recipients function of our list component. By the way, with the worker-to-worker communication, there is a blocking and a non-blocking version of each exported function, so you can even interleave invocations of multiple remote workers. And this is the place where we would actually send the email. I'm not demonstrating that, but you can imagine using an HTTP library or a library that uses HTTP to use some kind of external service like SendGrid or whatever to send an email to each of these email addresses. And getting the deadline is the same thing, initializing the worker-to-worker communication, calling one of the exported functions, which is returning it as an epoch millisecond. So in order to compile this and to be able to uncomment this last part here, which is really just calling this send email function that we were just looking at. I'm not going to do that because that requires like 6 or 8 more CLI calls to generate the stubs and add the stub dependencies and compose things together and so on. You have to do it in both directions because in this example, the list and the email are both calling each other. So here we are calling the email worker, then the email worker is calling back these two methods. So it's a bidirectional worker-to-worker communication. It's documented in the README file and not very complicated to set this up, but probably not very interesting for the demo. So what I'm going to do is to just demonstrate the final version. There is a precompiled directory here. Yeah, so I have the final version of these, and I will hope that you believe that this is the same thing that we were just looking at, and I'm going to first, where is it? Almost done. Yeah. Yeah, so first we are going to upload the new component called email. And store this. And then we are going to update once again our list component to this. And we actually didn't modify anything in the archive component, so we don't need to touch that. And once again, so now we can see the two new exported functions here. And once again, we start explicitly our new list called test4. And this time we are not only passing the archive components identifier, but we are also passing the email components identifier that we just deployed up here. So let's once again create some items in our new list. And it's still working. And what I said is that for each list worker, there is a companion email worker now, and we can verify that by listing the email, all the workers of the email component, and we can see that, yes, there is one with the same name called test4, and its status is suspended. And that is interesting because suspended means that it's sleeping. So it was working, it detected that it has to sleep for 12 hours and now it's sleeping. And the last thing that we can do, I'm not going to wait 12 hours now to test this, but we can check the logs of our email component like this. And we can see that it was getting the deadline from the list worker, and it got a deadline. It's not printed in a very nice way, but it's waiting basically 12 hours from now. And if we would wait for that, it will eventually print out that it's trying to send an email to me. So that was the demo, and I hope you enjoyed it. And now I'm handing it over to my colleague Nico, who is going to show the web-based user interface that you can use to manage your Golem workers and components and everything you have.
Hey everyone, I am Nico, and I am going to talk to you guys about Golem Cloud. So let me share my screen. Sorry, 1 second. So what is Golem Cloud? So Daniel kind of walked you through what Golem was, like the process of developing applications and components and then deploying them and such. So Golem Cloud is a hosted offering of Golem that we manage for you. And so it helps you develop, deploy, and manage workers and components with a lot of things built out. And it also gives you the console. So the console is something like AWS console, just a user interface that lets you manage and interact with these things. And yeah, let's get right into it. So I'm going to walk you guys through pretty much the entire process of managing a component, starting a project, and all of that. So we'll start off by visiting the console. So it's available at console.golem.cloud. So first time that you visit, you'll have to sign in. And then you're met with your dashboard overview. So it gives you the rundown of kind of what the current state of affairs is. And we're going to go ahead and navigate to projects. This is going to bring us to our list of projects. So for the sake of this demo, we're going to create a new project that's going to build off of, or basically use the same components that Daniel wrote. So we'll say list editor demo. And we'll say it's the launch 1.0 for the description. And that'll bring us into our project. And so in order to do anything in a project, we have to upload components. And so we'll upload each of them one by one. So we have basically 3 components here. We have the list component, so list editor. We'll upload that. And so this takes a little bit strictly because we're doing a lot of optimization here. Like we're basically taking the WebAssembly module and compiling it down to something that basically doesn't have like strong cold starts or anything. So we're doing that. We're also introspecting the binary to see what the exports are and those sorts of things. So we'll go from list. We'll also upload email. Perfect. Just one more. Now we'll do archive. So now if we go back to our project, the all components view, we'll see that we have each of our components and that we have no workers, no active workers on any of them. So now that we've uploaded our components, let's go to list editor. List editor is kind of the one that spawns the other ones from the demo. So we can go ahead and create a list worker, a list editor worker. So we'll call this list 1. And so basically, because this relies on that worker-to-worker communication, we have to know the component IDs of the other components we're communicating with. So we're going to go ahead and select the component IDs. So we have to interact with the email, and we also have to interact with the archive components. And so what this does basically is inserts the component IDs for both of these things, for both of these components. And so those are available under these environment variable keys. So we can go ahead and create this worker. Sweet. And so once we have created a worker, we basically get some pretty cool things right off the bat. So we can see that we have received the environment variables that we set here. we can also see that we can, at any time, while the worker is executed, we can look at its output. So that we haven't done anything with it yet, but we'll come back here. And a really cool thing is that we have this invoke page. And so what this is like a mini IDE that basically, based on the types of your WIT functions, the things that you're exporting, it'll basically generate a form for you so that you can on the go just fill what you need out, and then it will give you the responses. So it's a really like convenient and playful way to be able to interact with your workers. So it's kind of like Swagger UI taken to the next level. So before we are able to add anything, you can see all of the exports are here on the sidebar. So we can start by connecting to the worker. So I'm going to connect myself. So that's my email, invoke, and that went through. So I got my connection ID of 1. And let's go to add. So now that my ID is 1, let's add some items to the list. So we can go ahead and invoke, and let's add another one, 3, so that there's kind of a hole in the middle of the list. So then let's go to get. So this will retrieve the existing list. And you can see that we have our items added 1 and 3. And so let's also do an insert quickly. So after 1, we'll put 2. Invoke that, go back to get, invoke this. Now we have our completed list, 1, 2, and 3. And so to show you the execution order, like Daniel's components had logs. And so basically every step of the way, you're getting exactly what you logged, and you can see that. And if this page was open during when I was invoking them, they would stream in. So super like simple and easy. And you pretty much don't get anything like this on any other platform. So it's a really convenient way to basically introspect the state of your programs, the state of your workers, and those sorts of things, and interact with them. So if we go back to let's visit another component. So basically, so another thing that's interesting is if we're in the list editor component, we can see and just search for all the workers that exist. So we made this one, so that's kind of we'll jump back here. And one thing that I neglected to do is archive. So because we haven't archived, this will come back false. So, but we're going to go ahead and archive this list. So we invoke that, success. We check is archived, should be true now. Perfect. And now let's jump all the way back to our project components. And so now we can see that we only created one list editor, but through the worker-to-worker communication, it spawned an email and an archive worker corresponding to this list. Well, the archive one's global. But we can actually just go ahead and look at those quickly. So we're at the email component, go into workers, view the worker details. We can look at the terminal real quick, and we can see that we got the deadline and that it's sleeping for 12 hours. So we can see that went through perfectly. And then we'll quickly step back out to archive, go to workers, find the worker. This is the global archive singleton worker. And another thing that's cool here is that the way that the environment is configured is that when you spawn a worker from a worker, the environments are inherited. So we basically set these two, email component ID, archive component ID, up at the top, and this worker gets it through that environment inheritance. And so if we look here, we can actually do a get all on the archive. And this will come back and give us that we had archived that list, and that worker's name was list 1. So all of that very quick and easy, and that it received the list command and it logged this out to the console. And so that's like a kind of a brief overview of some of the things that are available. I also just want to emphasize how simple this is, like the fact that you can kind of zoom into any worker, look at its state. Like this is a lot more interactive and has a better level of granularity than going on Kibana and then searching for a different thing ID, things ID or a trace ID and trying to associate logs and all of this. Everything is kind of confined to this one worker space, and all of them have their durability guarantees and all of that. So it really promotes a new type of development experience that the console aids you in. And I think Golem Cloud will help many people develop a lot of great apps. So with that said, the one thing that we haven't explored yet, so we've explored developing components with Daniel. I gave you an overview of what Golem Cloud provides on the worker and component basis. But the one thing that's missing is, let's say you want to use something like Golem Cloud to solve one part of your stack's important business problem. But like you still have things running in other places. You still have services running in AWS. You still have services running elsewhere. And you want to be able to expose your workers to traditional cloud compute programs. So we've solved this problem in a certain way that lets you kind of expose workers via a REST API, and that's like it's something that you can custom build. And Afzal is going to break that down for us. So without any further ado, Afzal, you can take it away. Afzal, you're muted.
Thanks, Nico. That was a good introduction to Worker Gateway. So I will be explaining this feature in Golem called as Worker Gateway that allows you to expose these worker function as HTTP API endpoints. So let me explain that a little bit. So now that we have seen Daniel developing a collaborative list editor, in fact, a production-grade collaborative list editor in 45 minutes. And in order to achieve it, he has written a lot of functions using components and all the features that Golem ecosystem has given us. All the with API interface, the worker-to-worker communications, different languages. But end of the day, there might be instances we still need to interact with these workers in a normal way without getting into the nuances of Golem ecosystem. So for that, we have developed this feature, which we call Worker Gateway. Sometimes we call Worker Bridge. And this will allow you to compose these HTTP API on top of all these functions that we just built. So I have already uploaded Daniel's component into my project, just like what Nico has done and demoed right now. So that functions are already available for me to interact with. So there is another example that always keep coming to my mind when it comes to exposing APIs. If you're building, for example, a distributed computing platform within Golem, because Golem is able to achieve that really nicely. Now we need to understand the progress of each of these worker functions, the state of each of these worker functions, or in fact, maybe to get the subcomputation result of the bigger computation at various points in the Golem ecosystem. You can simply compose an HTTP API that points to these different worker functions. And now you get almost a monitoring tool geared to solve your company's use case. So let's see all this in action. But before I begin, I want to also give an introduction to a language called Golem RIP. So why is that needed? The problem here is every input that is contained in the input HTTP requests may not map directly to the input of the worker function. Your worker function might be expecting a record, but all that we have is an ID in the input HTTP request. So we need to massage this input. We need to manipulate this input before we feed this into the worker function. And this goes to the output as well. The output of these worker functions may need to be changed, may need to be transformed before you send it as HTTP response. So that says we need to be able to transform this input that is coming from an HTTP, call the worker function, one or more worker functions, in fact, and then transform the output and then form a result that makes sense as an HTTP response. So this is achieved using a language that we have built called RIP, aka Golem RIP. And it's a typed scripting language. It knows what you're writing. It knows about all the input that is required for these functions. So it's compile time to a great extent. And let's see all of that in action. So with this language embedded into the worker bridge, what you are getting is almost a backend service for free, something that you can configure quickly. So here is one of the endpoints that I'm configuring that points to one of the functions that Daniel has already written. Now, this is something that's a path that I wanted as an HTTP endpoint. It takes a path parameter. I'm naming it as name. I selected the component. We know it is LST component. And then I'm giving some name to the worker. Now, here is the interesting part. Now, this worker function called connect takes an email as input. However, the request path parameter is just a name. So this is a very simple example of I'm appending the name that comes from the request. This clearly shows RIP can point to the request path parameters and request body parameters, etc. And then I'm appending that with a constant string. And then I'm passing that email to this function. And the number of functions, like the list of functions that are available to that component is available here as well. And you can also go to the component page and see for yourself these functions, what it takes and what is the output that it is giving, and etc. So that's one of the routes that shows you're transforming the input before you feed it into the worker function. Let me give you another example, which takes the output of the worker and transforming it before I send it as an HTTP response. So here is a get method. I selected the get method. This is a path of our HTTP endpoint, and same component version, and same worker name. And then I'm calling isArchived function. We have seen this function, Daniel developing this function. The output of that function, if I go to isArchived, it is a Boolean, and it returns a bool. And what I need as an HTTP response is a clear text indicating whether it is archived or not. So with RIP, you can write a simple if-else condition. And then if it is archived, I'm going to say archive, otherwise unarchived, and I'm passing that result as it is into the body. You can give a status. You can also add headers. There are so much possibilities within this RIP functionality. And so that's one way. Let's go into the add method, which shows an example of RIP peeking into the request body. So here is RIP taking connection ID from the request body instead of request path. So everything else is almost the same as that of other endpoints. And it's also post instead of get. And then I'm calling that function add, which takes two parameters, connection ID, which I got it from the request body. And here you can see I'm taking the request body and forming a record, because add function takes a record and not a raw ID value. So I'm forming the record there, and then I'm passing that as a connection ID to the add method. And I'm passing value field from the request body. Now you can also see that RIP is now aware of the input requirements. What is the input? Whatever that you have given as a request body or path parameter values into the HTTP request. So RIP knows what should be your request by the time you upload this API definition. So it's compile time known. So while the error message needs to be cleaned up, this is an example of showing that this could fail. Now I'm not going into the error message, but it clearly means you cannot change that to one parameter because add function takes two parameters. So we are not changing anything else there. We are keeping those transformations as it is. So what next? So we have developed this API definition under the component, under the project. And now we need to deploy this API definition into a domain. We have got an in-house domain API, Golem Cloud. We are going to deploy that there under any subdomain. So let's do that. So I'm going to call this, I obviously have done this a couple of times. I'm going to call this maybe V6. And my API is list editor V1. And you can see I have already published a lot of those versions, me testing RIP and API gateway. So I'm going to select 1.0.3, which is a draft version, which you have just seen. And I'm deploying it. Might take some time to get it working, but let's see. So it's deployed successfully. So let's go into a curl command. So it's list editor V6. And the connected editors, you get a new list. You get an existing list because remember that I'm pointing to the same workers essentially. You can connect, you can use connect command, say pass John. Now you get a response back. And whatever response that worker is giving, you will get an HTTP, a JSON mapping for that. But obviously you need to make sure that you're sending proper HTTP responses. So I think that should have given some gist of how you can configure these APIs, these HTTP endpoints over these worker functions instead of getting into the nuances of Golem ecosystem. Now a UI developer can come in and use those APIs and develop a simple UI on top of our collaborative list editor. I hope you enjoyed it. Thank you, everyone. I'm handing this to John.
Right. Thank you so much, Afzal, and thank you, Daniel and Nico, for that excellent demonstration of the power of Golem. I think if you look at that and see how much functionality was built in such a small amount of time, multi-user collaborative editor, basically a whole backend, including custom API, with logging and all this other rich functionality, and it's scalable and it's reliable and it doesn't use any databases. It doesn't use any complexity. It's nothing but Golem and in-memory data structures. While not every single application will not require a database, there's many reasons to use a database. And some applications maybe won't require that degree of like bulletproof reliability. I think you can see here that what we're dealing with is a new type of computing platform with the potential to radically simplify how people build reliable distributed applications. So now I'm going to go ahead and share my screen and we will wrap up. Here we go. And what I'm going to try to do is make this full screen. Okay, there we go. So Golem Hackathon is coming up a week from Saturday, and it's going to be a phenomenal chance to learn more about Golem, get hands-on with this type of technology, and maybe even build your first backend or web service or other application on this Golem technology. And in addition to Golem contributors being around to help you out with questions and to basically get you started, give you hands-on assistance to get started, we are giving away more than $5,000 in cash as prizes. We're going to have a first place winner, second place winner, and third place winner. And that will be decided by judges that we will announce shortly before the event. The whole event is going to kick off on Saturday at 9 a.m. Eastern Time on August the 31st. And you're going to be given basically the set of problem requirements in order to make sure that no one starts today and gets way ahead of everyone else. What we're going to do is basically have a theme and a set of requirements for your submission that you're going to come to understand next Saturday at 5 a.m. And then things will kick off in earnest at 6 a.m. when you're free to begin work, either alone or in a team, if that's what you prefer. And then things will wrap up the following day at 1 p.m. Eastern Time, where we will basically close off coding and proceed to project demos. So everyone will have an opportunity to take 2 or 3 minutes to demo your work for the judges, and then we will go ahead and do the judging and announce winners. So I'm going to temporarily, actually, I don't need to, right there on the screen, actually, you can see bit.ly golem hackathon. So if you want to participate in the hackathon, you must pre-register. And you pre-register by going to that bit.ly link there and entering your details. All right, summary. First off, every modern cloud app is distributed. And that's because the applications that you're building today, they don't just store information in a single relational database. They store it across dozens, maybe hundreds of different web systems and databases and queues and caches, key value stores, blob stores. That's the life that every single developer has to deal with when they're building modern cloud native applications. And that complicates things tremendously because we don't have a reliable way to update state anymore. If all our state's in a single relational system, it's easy, we do SQL. But if it's not, if it's scattered across many systems, then we're updating all these systems using code. And part of the reason why it's so hard to build reliable distributed applications today, the main reason, is simply because we don't have the ability to transactionally execute code. You can't say, I want all this code to be executed as part of this transaction that's going to touch all these different APIs and databases and systems. We don't have that ability. Well, Golem gives us that ability. Golem gives us the ability to transactionally execute code. And that, in turn, gives us durable state and all this other stuff that helps us, in some cases, to just delete the database. And what it leads to is a radical simplification in the way we build highly scalable, bulletproof, reliable, distributed applications. And you caught a glimpse of that today. There's much more to say about that, I think. And there's some open source projects that are built on Golem, like Golem Timeline, that are truly incredible. And you should definitely peek into those open source projects if you want to gain a glimpse at the full expressive power of something like Golem. We've seen today the set of features that have been incorporated into Golem 1 that were demoed by Daniel, including worker-to-worker communication and environment variable support and live logging and all the stuff we've managed to pack in here. And we really do have that set of features that is necessary to start delivering value. So we encourage all of you to go out there and build an application. It doesn't have to be a production application. Build something simple. See what this does. See the 10 times or 100 times improvement in your productivity or in your distributed systems reliability, and gain a glimpse into the future of cloud computing. Golem is not the only solution out there in this space. There's plenty of other great solutions. And I think there's space for everyone in this market to really deliver a tremendous amount of value to developers who are looking for high reliability with simple code. Don't miss our hackathon, which is next Saturday, 5K in prizes. And I encourage you to sign up to the newsletter, Golem newsletter, follow Golem Cloud on X, or follow me at JD Goes. Join our Golem Discord if you've not already had a chance to do that. And you can either hack on Golem yourself at that GitHub link shown on the screen, or if you're not in the mood to hack on some low-level sort of infrastructure level software written in mostly Rust, then please at least star that GitHub repository to show your interest and support of this new open source project, and then subscribe to the official Golem newsletter, which you can find at http://golem.cloud. In addition, we have a basically brand new developer center now on Golem Cloud. So if you previously visited Golem and thought, well, this sounds nice, but how do I actually build something? Well, we have news for you. We actually have instructions on how you can use Golem to build a system. And there's this open source project that Daniel created as part of this demo that you can find. And then there's a whole bunch of other projects that are created on Golem, and will give you a sense for how you get started building applications on Golem. So I want to thank, first off, all of the attendees of this live stream for coming here and letting us have 2 hours of your time to talk about what we're so excited about and what we've been working on for the past year and a half. I also want to thank our marketing department for getting the word out there at this event. I think we had an amazing number of people who were tuning in. And I also want to thank our team here that you see today for working together hard on this demo and to show you the sort of full life cycle of building for develop for Golem, using our cloud-based management tool in order to simplify some aspects of development and operations and monitoring and so forth. And then also, how do you build custom APIs on that? We've done the whole picture here, and I want to thank our fellow contributors here, Daniel and Afsal and Nico, for doing a great job of that. And then I also want to thank our Golem team, our broader Golem team. Golem team is not big, but there's a few more people that you don't see here who have put a lot of hours, I think, into making Golem everything that it is today. So join us on this new journey. And keep in mind that this is 1.0, so there's lots of features we know we need that we don't have now. Tell us what we should work on next. Give us feedback. Open issues on GitHub. Open pull requests if you're brave enough to contribute. Give us feedback. We're still looking for, I think, a couple more design partners. So if you take a look at this technology and you're like, yes, this is the technology that I want, and you're willing to work with us closely to help you be successful, which means getting sort of priority input into features and all that good stuff that are coming down the pipeline, then reach out to me personally, either on Discord or send me an email at john@zyverge.com, and we will get you signed up for our design partner program, which will give you priority support, helping you move all the way into production and making sure that we fully support you in that task. And otherwise, just, start playing around, blog about what you do, create open source projects, anything that you can do to help get the word out about what we're doing and to show people that building these distributed systems can be 10 or 100 times simpler would be enormously appreciated and will help us move faster. All right, thank you so much, everyone. I look forward to seeing hopefully many of you at the hackathon next Saturday.